Hello, and welcome to Math with Asna. In this lesson, we're going to talk about identifying relationships, specifically within lines. We'll discuss these types of relationships, we'll learn some theorems and postulates, and how to use them. We've got some vocabulary. First of all, parallel lines are two lines that do not intersect, and they are coplanar. They are on the same plane. Skew lines are two lines that do not intersect, just like parallel lines, but they are not coplanar. So the difference between parallel and skew, parallel lines are lines that are on the same plane. Skew lines are lines that are not on the same plane. Parallel planes, two planes that do not intersect. Example of this could be like your ceiling and your floor. Those could be two planes that are not going to intersect. A transversal is a line that intersects two or more coplanar lines at different points. This seems like a bit of a wordy example, but really what we would have is two or more lines and another line that goes through them and intersects all of them. So this line here would be a transversal because it's intersecting all of those other lines. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles, we are going to discuss those when we actually go through the example because they're easier to understand if you can see them. Two postulates today. We have the parallel postulate, which says if there is a line, I'm going to go ahead and make a line. So if there is a line and a point not on the line, then there is exactly one line through the point that is parallel to the given line. Remember in geometry, if it looks parallel, doesn't mean that it is parallel. The way that we show two lines are parallel is by putting those little arrows on there. So by using that notation with the two arrows, that shows that the lines are parallel. The perpendicular postulate, there is a line, so I'm going to make another line, and a point not on the line, then there is exactly one line through this point that is perpendicular to the given line. And just like for parallel lines, we cannot assume that these are perpendicular. We would need to use that notation to show that they're perpendicular. Let's do an example of skew lines. Now, the reason I have a box here is because skew lines are lines that are not on the same plane. It's a lot easier to see them on a cube as opposed to trying to draw it out. What I'm going to do is make two lines on different planes that don't intersect. So I could have, let's say, one line right here and maybe another line down there. So I have two lines, they're not going to intersect, and they're on two different planes. Let's identify each of those four types of angles. When we have two lines or more than two lines and a transversal, we can have all of these types of angles. What we're going to do now is just learn how to identify them. So my two lines are these two right here. These are my two lines. And this is my transversal. This is the line that is intersecting those other two lines. I've got a bunch of numbers here. You don't see the degree measure next to them, which means these are the names of the angles. They're not the degrees of the angles. What I do is I start off by just putting a box around my lines, around my angles. Corresponding angles. What you're going to look for is the location. The location of one angle on one line matches with the same location on the other line. What does that mean? So if I look at this angle 1, this is one angle that is on this transversal and one of the two lines. If I want the angle that corresponds with that, I want to look at the angle that's in the same position but on the other line. Now my angle 1 there is in the top left corner of my box. So I'm going to look for the angle that is the top left corner of the box on the other line. So angle 1 and angle 7 is one pair of corresponding angles. I can also have angle number 2. That's in the top right corner, which matches with angle number 5, angle 2, and angle 5. The bottom left corner is angle 3 on one line and angle 6 on the other. Angle 3 and angle 6. And the last one, angle 4 is the bottom right on one line and angle 8 is the bottom right on the other line. Angle 4 and angle 8. All right, I'm going to go ahead and erase this so we can talk about the next set. So our next set is consecutive interior angles. You might also hear these called same side interior angles, just another name for it. Interior means inside those two lines. So these two lines have an interior, all this, and they have an exterior, all that. We want the interior, which means I'm going to cross out the angles that are not going to work, the angles that are on the exterior. So consecutive interior, we took care of the interior part. The consecutive part means it's going to be on the same side of that transversal. That's why sometimes these are called same side interior. So interior angles on the same side of the transversal, angle 2 and angle 7, and angle 4 and angle 6. Let's do the next one. Alternate exterior angles. If I'm talking about the exterior now, that means I can't use any of these angles. Alternate means on opposite sides of the transversal, which means if I start off with angle 1, my next angle has to be angle 8 because it's on the other line on the opposite side of that transversal. Angle 1 and angle 8. I could also have angle 3 and angle 5. My last one is alternate interior angles. So again, I'm talking about interior, which means these angles are not going to work because they're not on the interior. Alternate, just like before, means on opposite sides of that transversal. So if I have angle 2, it would match up with angle 6. And if I had angle 4, it would match up with angle 7. And there we go. We've got our 4 different types of angles. Notice that corresponding angles are the only ones that have 4 pairs, and the other 3 only have 2 pairs. If you learned something, please like and subscribe, and stay tuned for more videos.